Alright, ladies and gentlemen, today you're going to be working on Lesson 5-7, Solve Problems Using Arrays. It's going to be on page 189. It's going to be on page 189. Focus. Here we go, 189. Oh, that's still not focusing very well, is it? There we go, 189. That's where we're going to start today. What question could you ask? Kayla needs to add the same number of flags to each swimming pool lane for an upcoming of meet. Well, that's a pretty straightforward question. Well, if this is the lane, then she's going to have to put a flag here. If this is the lane, she's going to have to put a flag here. If this is the lane, she's going to have to put a flag here. So here, 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 here. So it's just like rows, isn't it? It's just lanes in that. It's just lanes. So going down, so if you count the rows, then that's how many flags she would have. What helps you know when there is a problem? Good question. Alright, let's look over here to our learn. Our learn is Kayla needs to add 8 flags to each 9 swimming pool lanes for an upcoming meet. Apparently they're wanting to add multiple flags in the lane. Alright, how many flags does she need in total? Draw an array, we know what the word array means, and write an equation, we know what an equation is, to represent the unknown, we know what an unknown is, that's like the question mark, or it can be a letter or symbol in the problem. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 columns. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 rows. Alright, so our equation is going to be 9 times 8. And then there's our unknown. Now that we're going to decompose. We know what that word means too. Break apart. Decompose a factor. We know what a factor is. It's the two numbers that we multiply together to help you find the product. We know what the product is. It's an answer to a multiplication problem. So 9 times 8. We're going to break apart 9. So 9 gets broken to 5 and 4. We keep 8 the same. Then we multiply. 5 times 8 is 40. 4 times 8 is 32. Then 40 plus 32 is 72. So our equation, 9 times 8 equals 72 is our product. There's our sentence answering Kayla needs 72 flags. Alright, so let's look below this. It says, you can represent a multiplication problem with an array and equation. We know what array is. This is the array, so we're having to draw it. And an equation is an equation. You can decompose. We know what decompose is, to break apart. A factor. We know factors are multiplied together in a multiplication problem to help you solve the problem. Alright. Now look, over here it says, how can you decompose 8 instead of 9 to solve the problem? So if we went up here, we could break 8 down into 5 and 3, couldn't we? Or 8 can be broke down into 4 and 4, the doubles. Alright, now it's time to work together. I want you to work this problem out. An artist places 7 clay bows on each 6 shells for display case. How can you decompose a factor to find the number of bows the artist displays? Alright. I'm going to read it again. An artist places 7 clay bowls on each of the 6 shelves in a display case. Alright, so let's think. I like to make sense out of it. So if we've got 6 shelves, 1, 2, 3, 4, 5, 6. There's 6 shelves. This is me thinking of a cabinet. And if I've got 7 clay bowls, that means I've got 7 on this line, 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 and 7 on this line. This is me thinking of the problem. I don't like how much that shakes. There's not a whole lot I can do about that though. That's we got right now. Alright. So, our equation, how can we decompose the factor to find the number? So let's write our equation first. We're going to do 7 times 6 equals our unknown. Oh, we always do A for answer. Let's use a triangle this time. Let's use a triangle. Alright, for our unknown. Now, we can decompose our 7, or we can decompose our 6. I'm going to decompose the 7. So I'm going to break that down into 7 times, oh, I didn't decompose the 7, did I? I'm going to decompose the 6 then, since I wrote the 7. 7 times 5, I like putting that in parentheses, plus, so if I decompose that, it's going to be 7 times 1 is my other one. Let's double check. Kept 7 the same. I decomposed my 6 to 5 and 1. So now this one is going to be 35 plus 7, which is going to give me 42. How can you decompose a factor to find the number of bowls the artist displays? So now I have to write my sentence. The artist, there it goes shaking again, that's driving me insane. The artist displays 42 bowls. And we have answered the question. Alright, now we're going to, this is page 190. We're going to move over to page 191. Page 191. Alright. Alright. How can you draw an array? So we have to draw an array to decompose a factor to show us work. So we've got to draw an array. A box of soup can be arranged in 8 rows with 6 cans in each row. How many cans of soup are there in the box? Alright, so we got to draw an array first. I have 8 rows of 6 cans. So 1 row, there's 1 row of 6, 2 rows of 6, 3 rows of 6, 4 rows of 6, 5 rows of 6, 6 rows of 6, 7 rows of 6, 8 rows of 6. You have to draw this. If you're not writing in your book, you need to be writing in your book. If you're not writing on the page. Alright, now I need to write my equation. So my equation would be 8 times 6 equals my unknown, which, since it's soup, I'm going to put an S for cans of soup. That's going to be my unknown on this problem. So now I need to decompose. I can decompose my 8 if I want to. I can do 4 and 4. I can do 5 and 3. I can decompose my 6 into 5 and 1. 5 and 1 sounds a lot easier, doesn't it? So that's what I would do. So I'm going to decompose. I'm going to leave 8 the same. And I'm going to decompose my factor of 6 to 5 and 1. Oh, that's a plus sign. We're not adding, we're multiplying in our parentheses. So I'm adding the partial products afterwards. Alright, so now 8 times 5 is 40, and then 8, and so S is going to equal 48, because that's my unknown. That's my unknown. So now I've got to write my sentence over here. How many cans of soup are there in the box? So there are 48 cans of soup in the box. Period. Alright. So did we do what we were supposed to? We drew an array, we decomposed our factor, and we showed our work. We answered with the sentence. Alright, on number 2, the cafeteria has 6 tables and 4 seats at each table. How many seats are there in the cafeteria? The cafeteria has 6 tables and 4 seats at each table. Alright, so 6 tables. Now, I don't like the idea of drawing an array for this one, but I can. But me making sense of it, if I've got 6 tables, I've got 1, 2, 3, 4, 5, 6, and I've got 4 seats at each table. That means I've got 4 here, 4 here, 4 here, 4 here, 4 here, 4 here. This is me making sense of it. And then from here, I know I can do 6 times 4 is my equation. But they're wanting an array, so I'm going to have to draw an array. So I'm going to do 1, 2, 3, 4 in my array. 5, 6, 7, 8. Alright, so I've got 4 and 6. So this side's 6 and this side is 4. Now I can write my equation, which is 6 times 4. Now I can do the properties of 4 on this one and do 6 times 2 and 6 times 2. Or I could break 6 down to 6 times 4, or 5 times 4, and then 1 times 4. Because we're decomposing a factor, I'm going to choose to decompose 4. So that means I'm going to have 6 times 2, because I know I can double my 6, and then 6 times 2 again, and I can double my 6 again. So then I have 12 plus 12, which is 24. Oh, I didn't put an unknown. We've got to put an unknown. So 24 equals, let's put T for table, T for our unknown. T is our unknown. So 24 is equal to T. We've got to, how many seats are there in the cafeteria? There are 24 seats. Seats is our unit in the cafeteria. Guys, and I'm just pulling the words from there. So if you have trouble spelling, you pull the words from your word problem. Alright, let's look down here. Okay, so we've got to complete the equation. They're wanting us to decompose this. Now, would I decompose this one? I would not. I would not decompose that one because it's a 5 and I can count by 5s. I can count by 5s and go 5, 10, 15, 20, 25, 30, 35, 40. Let's make sure we counted 8 times. 1, 2, 3, 4, 5, 6, 7, 8. We did, so our answer is 40. Our product is 40. Alright. Oh my goodness. This shakes way too much. And it's not my table, it's my little document camera. Alright. Blank equals 7 times 6. So I can decompose this. I could break this apart and say, okay, I've got 7 times 5 plus 7 times 1. Then I've got 35, and I've got 7, which gives me 42 as my product. Alright. Let's go on. We've got 6 times blank. Oh, this is a division problem. This is a division problem, so I've got to put it in rows of 6 till I get to 54. Or I can use the opposite, which is multiplication. So there's 2 different strategies I could use here. I can make my array and count, or I can say, well, I know 6 times 5 is 30. So if I use 30 out of my 54, I have 24 left. And I can go, okay, well, 2 times 6. 6 times 2, commutative property, is 12. So then I use 12, and I have 12 left. So then I can do another 6 times 2 and get 12 again. And then that means that I'm down to 0, and I can compose my factors back together and get 9 as my answer. Or I can flip it around and you do a division problem, which is 54 divided by 6 equals, alright? And I could do, okay, I've got to put it in rows of 6. Or I can see how many times I have to add 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. So I've used 54 total dots, and I've got 6 going across here, so I've got to count down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 going down here. And I've used a total of 54, so my answer would be 9. This is repeated addition, or you could do repeated subtraction. So you can use either one of them to solve. We've got 7 times 3. 7 times 3, I would honestly just know this one and put 21. But for decomposing a factor, let's break this one down. Let's say that I decompose my 7 to 3 times 5, and then 3 times 2, because 5 and 2 gives me the factor of 7. So that would be 15, and that would be 6, and when we add those together, we get 21. Okay? I've used so many strategies on the one above, it's going to be a little hard for the bottom one. Again, this is shaking and it's driving me insane. Alright, so 9 times 3. Again, I would just know my 3 facts by now. You could decompose it to this one being 9 times 2 and then 9 times 1. And I know that it's 18 and then 9, and when I add those two together, I get 27. Okay, so there you go. Cool thing about anything times 9, if you add the 2 digits together, you're always going to get 9. Always going to get 9. Alright, I've got 4 times blank equals 36. 4 times blank equals 36. So I can say, well, 4 times 5 is going to give me 20. So I can subtract 20 there. And I have 16 left. So let's do 4 times 2, which is going to give me 8. So if I subtract 8, I'm going to get 8 left. And then do another 4 times 2 is going to give me 8 again. So I subtract 8 again and I get 0. So I compose, that means I put them back together, the factor that I've got, so it's 9. 9. Alright. We've got blank times 8 equals 56. Well, I can do the same thing. I can say, well, 8 times 5 equals 40. So I can take 40 away, and that means I have 16 left. 8 times 2 is 16. So I take 16 away. It'll have 0 left. So put my factor back together, and it's 7. Alright. I got blank times 8 equals 72. Well, I can do my array. I can do my patterns, whichever way I want to do. Since I've got a lot of room over here, I think I'm going to go ahead and do my array. I want to go 1, 2, 3, 4, 5, 6, 7, 8, 1, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. So I used a total of 72 in my arrays. And I've got 8 going across the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 going down the side, so it should be 9. Now if I want to check this, I can decompose it and double check my work. Alright, I've got 8 times 4, so I would do 2 times 8 plus 2 times 8 because I decomposed my 4, which is 16 and 16, which is 32. Alright, I've got 7 times 4. I would decompose my 4 to doubles, so that means I would have 7 times 2 plus 7 times 2, which is 14 plus 14, which is 28. Alright, flip that page over. We got stem connection. Finn is drawing a picture of a hotel. The first floor has 9 hallways with 9 doors in each hallway. The second floor has 9 hallways with some doors in each hall. How many doors on the first floor? How many doors on the second floor if there are 6 doors in each hallway? Okay, that's a lot of reading, so we're going to read again. Finn is drawing a picture of a hotel. The first floor has 9 hallways with 9 doors in each hallway. So, oh my goodness. So if this is 1 hallway, 2 hallways, 3 hallways, 4 hallways, 5 hallways, 6 hallways, 7 hallways, 8 hallways, 9 hallways. Alright? And he has 9 doors on each one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Phew! 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so this would be my array. I got off a little bit. Let me count and make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I just made my circles bigger. So this is the array for how many doors on the first floor, because it says the first floor has 9 hallways and 9 doors. So my equation would be 9 times 9 equals, I don't know, I'm going to put F for first, for our unknown. So I could break that down. I can decompose one of the factors to 9 times 5 and then 9 times 4 to be able to get to my answer. Or I can just know that it's 81. So the first floor has 81 what? Doors. That's my unit. Doors is my unit. How many doors on the second floor if there were 6 doors in each hallway? So we still have 9 hallways, but 6 doors. So that would be 9 times 6 equals second floor, S. So I can decompose my 9 times 6. They do not give us enough room. It drives me insane. All right. So I'd have to break down. I would have to have 9 times 5 plus 9 times 1. And 9 times 5 is 45. And 9 times, so it'd be 45 plus 9, which would give me 54. And remember our facts about our 9. If you add both digits together, you should get 9 for any 9 facts. So 54 doors. Do not like how much space they give us. Alright, Sawyer wants to find 7 times 9. She starts by drawing an array. Number the steps in the correct order to find the product. Oh, wow. Okay. This one's interesting. So, she finds the product of 7 times 4 and 7 times 5. She decomposes 9 into 4 times 5. She finds the product of 7 times 9 equals 63. She adds 28 and 35. Okay, so the first thing she did, if they hadn't gave us the product, I would have said that was the first thing, because the first thing we do is we find the equation. But they gave us the equation here. The next thing is she decomposes it, so that's first on this list. Then she finds the products, because you got to find the products, and then these are the products. And then when she adds these two together, she's going to get this is the partial products, and then she's going to get that. So that's our order. Whew. Oh me, let's say Grass tired. Braxton lost his homework assignment, but he still has his answer sheet for one of the problems. He drew an array with one factor decomposed into 5 and 2. What might have been the problem? Explain. Let's read this again. So Braxton lost his homework assignment, but he still has his answer sheet. So that means the answers. For one of the problems, he drew an array with one factor decomposed into 5 and so we know one factor has to be 7 then, right? Because 5 plus 2. What might have been the problem? And explain. Well, anything times 7, right? Okay. So here's where Miss Agra's brain overthinks this, though. Would it be 1 times 7? Because would you have to decompose it if it's a 1? No. Would you have to decompose it if it's a 2? A doubles? I wouldn't think so. But, you know, who knows? So I would actually start at 3 because that's what I would do. So it would have to be 3 or 4, 5. Oh my goodness, this could get big because you could keep going. Just because we've only went to 12s doesn't mean it stops there. Oops. Would you put 10 times 7? Because you automatically know what the properties of 10. I would skip 10 times 7. But I mean, technically, I guess you could do it. And guys, we could keep going. It could be 13 times 7. It could be 14. We could just keep going. Alright. So I think what it's wanting is you to explain that you would have to put 5 and 2 back together. 5 and 2 together. My T and my P went together, didn't it? Together to get the factor of 7, period. Then the other factor could be anything, really. Alright, we're not going to do the reflect. Make sure that you turn this in. You should have both pages done now. It's going to be turned in with your work plan. So you're going to go all the way back to 5-7. So page 189, 190, 191, 192. It should all be written down. Alright? And you should have a grade on it. So go ahead and write grade up here. And let me know what grade you got on this one. So go ahead and put your grade on this as well. Tear it out. Staple it. If you want to wait till the last day to staple all your papers at once, you can do that too.